Hello, this presentation is U.S. National Grid for Emergency Services. It was for Firefighting Today, Chief Pete Lamb, December 13th, 2015. My name is Al Stute. I'm a lieutenant with Cape Canaveral Fire Rescue and a communications and structure specialist with Florida Task Force 4. The objectives of the presentation: to expose U.S. National Grid to a wider audience, including the U.S. Fire Service, law enforcement, emergency management, etc. To steer leaders to a value-added, simple geo-addressing solution. To identify the need for interoperable gridded maps for all emergency responders. To demonstrate the ease of use of U.S. National Grid in daily responses. To advise about the various requirement documents and designations regarding U.S. National Grid use. To advise about smartphone apps and web tools. What is U.S. National Grid? It is an alphanumeric point reference system that has been overlaid on the Universal Transverse Mercator Numerical Grid. UTM has its origins 1947. It was developed by a citizens committee, the XY project, beginning in 1999. It was issued as a federal standard in 2001. There's the federal standard number. It is functionally equivalent to Military Grid Reference System, MGRS, which has been used by military and NATO since 1949. It is the language of location designed for inland use. From shore to shore, U.S. National Grid works fine. It is the designated coordinate system for land search and rescue since 2011 by the National Search and Rescue Committee. And what it can do is every modest size home in a discrete area, such as a city, can be described using 8 digits. And by adding a 2-letter prefix, the location is uniquely identified regionally or statewide. What U.S. National Grid is not. It is not latitude and longitude, which the general population likely may have heard of, but which has 3 version formats: decimal degrees, degrees minutes and decimal minutes, and degrees minutes and seconds. These multiple formats result in frequent errors and have caused significant response delays, such as during Hurricane Katrina and during the crashes of at least 2 helicopters. It is not a coordinate system that is difficult to learn, teach, or transmit effectively over the radio. It is not designed for long-distance air or ocean use. A cruise ship will not use it. A 747 will not use National Grid. It is not recommended to replace existing reference systems, such as street address, fire numbers, and facility numbers, but rather should be used in addition to those systems to augment them. U.S. National Grid components: the grid zone designator, the 100-kilometer ID, the easting, and the northing. An example coordinate would be 14 Sierra, November Golf, 5003 6660. Notice that it is just numbers and letters. There's no degrees, decimals, plus, minus, north, south, east, and west, minutes, seconds. U.S. National Grid is simple and is designed for ground operations. Here are some grid zone designators for the continental United States. Later we're going to do an example in grid zone designator 14 Sierra, which is highlighted there. We have grid zone designators in Hawaii, and there they are, 5Q and 4Q. And we have grid zone designators in Alaska. This is a worldwide system. We're just focusing on it for the United States. And this is the 100-kilometer ID component. On the left is 14 Sierra, and on the right we are going to focus on an example in November Golf later, which is highlighted now. The easting and the northing components of U.S. National Grid. Within that 100-kilometer ID, November Golf, I am 50% right and 66% up. So 50 right or east, 66 up north. That's where the location of that icon is, to a 1 meter precision. Excuse me, 1 kilometer precision. An example in Cunningham, Kansas, 14 Sierra, November Golf, 4963 6673. 14 Sierra is the grid zone designator. November Golf is the 100 kilometer ID. 4963 is the easting. 6673 is the northing. It's a base 10 system. The principal digits are the 1 kilometer grid square, which is 4966. 4966 is a 1 kilometer square. The 100 meter grid square is 496667. By just adding one digit, I can increase precision to 100 meters, and by adding another, I can get down to 10 meters of 4963 6673. In fire rescue use, emergency services, we do not need to use precision to 1 meter. Most devices have a precision, an accuracy of 3 to 5 meters. And so for routine use, we only use 4 in the easting and 4 in the northing. There will be smartphone apps and web tools and GPS receiver displays that will show 5 in the easting and 5 in the northing. And we just truncate off the last 1 meter precision digit. If entering data back into any system, you just use a 0 at the end. So here is a grid square of 4966 in Cunningham, Kansas. And as we zoom in, we can zoom in to 100 meter precision. The 494, 495, and 496 is like 49.4, 49.5, 49.6, like a decimal point. However, you don't say it that way and you don't write it that way, but that's what it means. We're 60% over and 70% up in grid 4966. Obviously, here's a ballpark, and that's a 100 meter grid square, 496, 667. And if I wanted to zoom in even further, I can zoom in to see the pitcher's mound happens to be in this grid square, which is 4963, 6673. So I'm 30% right and 30% up in 100 meter grid square, 496, 667. And again, this is a 10 meter grid square, 4963, 6673. 10 meters, 33 feet by 33 feet. The size of approximately 2.5 parking spots. So an example use, one of the things Chief Lamb wanted me to identify was how would you use this in daily operations? Well, per the statewide emergency response plan in Florida, if an incident commander was requesting strike team or a large number of resources to a major incident, in addition to the street address, they're going to advise the 1 kilometer grid square. So that coordinate is 14 Sierra, November Golf, 4963. That's been in effect since 2010 in Florida. In the case of 100 meters, that can be used to designate an LZ or helispot. In discussion with military and ex-military pilots, they clearly described that 100 meters is all they need, 3 in the easting and 3 in the northing, to identify a helispot. So locally, that is 496, 667, or regionally, if I needed to add a region to it, in case it was near a grid zone designator or boundary, or for whatever reason, November Golf, 496, 667. Back to the 6-digit version. In most cases, that would be needed for a ground unit to identify the location to an incoming medical helicopter, as an example. The fire service and EMS across this nation land helicopters all day long in football fields, baseball fields, softball fields, in the middle of intersections, and the amount of radio traffic to designate latitude and longitude and errors, etc., is noteworthy. US National Grid is the easiest to deal with. It can be done in 6 digits. And finally, the 10-meter grid square. What can be done with that? Notice these buildings here. If each one of the sides of these buildings had a door, you can differentiate between the doors of the front and back of any building, and these are very small dugout buildings. A regular house, it would be easy to see that the front and back door of any building could be differentiated by just 8 digits. Emergency location markers, which we'll get into, which is signs for parks, trails, critical infrastructure such as lift stations, all can be done with 8 digits in the local mode, locally per jurisdiction, or regionally, as in statewide, in 10 digits. U.S. National Grid uses: wide area events, brush or wildfires, searches, hazmat plumes, flooding, mudslides, tornadoes, hurricanes, plane crashes. These are all areas where U.S. National Grid can shine. Simple gridded maps, though, must be in the responders' hands. Infrastructure marking, lift stations, intersections, geo-addressing, shelters, points of distribution, fire numbers, and you can pre-plan anything. The most critical infrastructure in any jurisdiction is a lift station. Do you know where that lift station is when there's 2 or 3 houses or debris from houses on top of it? Can you find it? Can you find it easily? Fire numbers, familiar with that from the Northeast? Fire numbers, if they were going to be generated from scratch, could be National Grid numbers themselves, or they certainly could be geo-referenced and annotated. For every fire number, the National Grid number should be known. Pre-plans. You could pre-plan anything: hazmat, utility shutoffs, where the fire alarm panel is, where the front door is. And back to geo-addressing for package delivery, any EMS calls, E911. Identify which door the units need to go through, or deliver a package, or pick up something. You can identify an individual door. 362880, numbers with huge significance. Are you aware of what they are? 19 firefighters died at this position near Yarnell, Arizona, 30th June 2013. No position report of any kind was transmitted, and no mayday. The minimum position information that could have been transmitted, had the teams and anyone on site there knew National Grid, would have been 362880. The full coordinate for that location is 12 Sierra Uniform Charlie 362880. Unique, worldwide, 100 meters. Does your department operate in a wildland urban interface? Do they operate off-road or operate in the wilderness? What system do you use to refer to location? We just explained 1 kilometer grids, 100 meter grids, 10 meter grids. Personnel accountability, fire location, especially in the wildfire scenario. We can identify where people are easily in 6 digits. We can identify fire location, where the hazards are, where the safety zones are. Per the National Fire Incident Reporting System, 33% of all incidents are not at a street address. Fire rescue, EMS, law enforcement in this nation responds by and large to street address. Yet data shows 1/3 of those incidents are not at a street address. If we refer to street address as the Plan A method, what is your Plan B? Obviously, Plan B should be U.S. National Grid. This is hallowed ground in Arizona. This is a gridded map showing an aerial view of 362880, the location of where firefighters died in Yarnell. The orange is a fence line area, which is obviously restricted area, and you can see the size of the area. 362880 is the 100 meter grid square that could have been identified as the location. And now we're going to move into a hazmat example. This was presented to the Central Florida LEPC in October 2015. All agencies and jurisdictions are supposed to be familiar with large hazmat incidents. This could occur in any location in the nation. So we have a train incident with a leak in Central Florida. Here is a typical map, a paradigm map, non-gridded. There's the train. Some of this is repetitive because it's from another presentation, but in NFIRS we already talked about 33% of the incidents are not at a street address. Obviously this train is not at a street address. Where is it? It happens to be Flounder Creek Road, Brevard County, Florida. So we have an active chlorine leak from one of the cars. And this is what the First Due engine company has on their mobile data terminal. This is the map that they're looking at. It's also the same map that the CAD system has. In many jurisdictions, is this incident even dispatchable? How many have heard dispatchers requesting a street address to specifically enter that so that they could dispatch units? There's no street address at this train incident. So what are we going to do? Well, the recommendation strongly here is to add grid lines to maps. A map without a grid is just a picture, and a gridded map is a tool. These are certain takeaways from this presentation. If you're looking at non-gridded maps in your jurisdiction, you need to think about making those maps tools by putting National Grid on them. So we're going to identify this location to 100 meters, 1 kilometer. To 1 kilometer, this is in 1580. So using the rules of right then up, we plot right then up. So we're in 1580. And the 1 kilometer grids are also called principal digits. We happen to be in 100 kilometer ID November Mike. With no numbers on the screen there, you can see that that icon is 15% over and 80% up. Just you can read that without even a scale. 15% right, 80% up in November Mike. And as we zoom out, as identified, November Mike is the 100 kilometer ID. And as we zoom out, the yellow square is November Mike, unlabeled at this scale. And there's 17R. 17 Romeo is the grid zone designator. 17R is a grid zone designator, as stated. So some jurisdictions may have maps where National Grid are on, is shown. These are evacuation maps for hurricanes. Every county in the state of Florida has one. They're 10 kilometer divisions, which is okay. They're about 8.5 by 11 in most cases. And they're certainly better than nothing, and they're free. And so plotting the location of this incident, we are 15 over and 80 up, and we can identify that locally as 1580, or regionally as November Mike 1580, or worldwide it's 17 Romeo November Mike 1580. And as stated, the 17R November Mike 1580 is a state emergency response plan requirement when addressing the location and requesting large numbers of resources. So what can you do with a gridded map? Well, what we could do is we can geolocate the front and rear of the train. Obviously we'd be doing this with a handheld GPS or a smartphone and radioing that back to a commander who could take these numbers real quick. And notice that I'm in 150806 and 151802. So the difference here should be able to be seen as the 6 and the 2 are in the 100 meter location or digit, 100 meter digits. So 6 minus 2 is 400, so that train is 400 meters long. It's also the easting and northing difference is 100 meters. And I could get more defined if I wanted to, but this is just to 100 meters. I could use Pythagorean theorem. I got a little typo there, but we can deal with it. So I got 100 meters differential east and west, 400 meters differential north and south. If I do the a squared plus b squared square root, it's 412 meters, or 0.25 miles. You cannot do that with a non-gridded map or without the information. In latitude and longitude, you have to use calculus to figure it out. So here's our simulated train train car leaking. And this is 10-meter grid, courtesy of Mission Manager. And so the geoaddressing via US National Grid, as we discussed, is to 10 meters, which is good enough to find anything. Valves, parking spot, light pole is 1505 8057. Regionally, I can add the 100-kilometer ID for November Mike 1505 8057, and worldwide I add the 17R. And again, we have 10 meters, 100 meters, 1 kilometer. So, with numerous free web tools, GPS, smartphone apps, and gridded maps, the key is gridded maps, we can geolocate this leaking tank car or the front or back door of any business or single-family dwelling to a precision of 10 meters square in just 8 digits. And if I have to do it regionally, I can do it in 10 characters, 8 digits plus 2 characters. And yet, numerous computer-aided dispatch vendors still do not display in US National Grid. This is taxpayer-funded computer-aided dispatch screen. It is obviously obsolete with respect to what's going on with this presentation. It must be specified as a performance requirement to add US National Grid to maps. What do your CAD or mobile data terminal maps look like? What do your paper maps look like? So, for a train incident, per the emergency response guidebook, I'm supposed to evacuate 3,000 feet in all directions and 5 miles downrange. I chose an east wind to make it easy, and so there's what I'm supposed to evacuate. The paradigm is a non-gridded map. This is what we're used to seeing, is a non-gridded map. This is how we can make a map interoperable and make it a tool, by adding the grid. We can change the paradigm and we can make this mapping system a tool. So to determine the evacuation areas by 1 kilometer grid square, I zoom in, I can figure out what areas have occupancy, and that area in blue plus the yellow circle is all that I would need to evacuate if I chose to do that. And I would send teams by 1 kilometer grids. I could even split grids if I wanted to, and we can systematically evacuate this area. Except I noticed to the far west there was one location that had structures. So responders may have 1 to 25,000 map atlases, and they can be given their mission by maps that they already have in their vehicles. This constitutes pre-planning and is basically how this can be done at a grand scale. In Brevard County, it is, as an example, 2,500 map books were made and were issued and are supposed to be in every sheriff's department vehicle and fire department vehicle. And so that during an incident like this, they could pull out these maps and everybody can talk the language of location by looking at the grid squares that they're assigned. So we're going to evacuate the areas in blue. And as I said, the areas in red, there's some homes out there. So we can read the map by right off the scale, or we can put our mouse on it when it's live on the software and determine that the homes are at 075817. Somebody could take that information and be assigned to go find those locations and talk to the folks there. Imagine doing this without any grid reference system. There's no street address out there. Here's it. And so where is this location? I don't know. We could find it with National Grid, with a compass, with a map, and with a GPS routed to this location. Here's some of the tools that we can use. These are 2 smartphone apps. One is GMAP 4 on the left, and on the right is Mill GPS, which is Apple platform. GMAP 4 works on any platform. It's a browser app, and it has the ability to view GIS data. So you can put your hydrants for your jurisdiction and view them on a smartphone for free. The secret when trying to get apps for your phone is to look up MGRS in your app store. Daily use examples must be preceded by the issuance of gridded daily use maps. It's a leadership issue. Leaders must understand that we have to issue gridded maps. Once the gridded maps are issued, then routine dispatch information could include the U.S. National Grid coordinate. As an example, Engine 5, Truck 7, Medic 24 respond to 431 Main Street, grid 487529 for a structure fire. Now, how many main streets are in your county, city, or jurisdiction? U.S. National Grid Square makes it unique. For the first due engine companies and first due companies, they may not need to know the grid because it's in their first due area. They should know where that is. But what if on a day there's a major incident going on and you have mutual aid going to that structure fire, or you have a station backfill issue where an unfamiliar apparatus crew is in your quarters and they're going to go to this structure fire, and you want them to perform to the same standards as you want as far as timeliness to get to the scene. They may not know where 431 Main Street is, but they should be able to look at a gridded map and identify the 487529 and respond accordingly. Trails examples. Trails can be marked with U.S. National Grid, as can ballparks, any area that is not typical for street address. We have a Lake County, Florida sign here, which has the letters GPS on it, which has no value to the information at all. And we also have decimal degrees format for the latitude and longitude, which is not the standard search and rescue format for latitude and longitude. It's actually supposed to be degrees, minutes, decimal minutes. So this is the incorrect version of latitude and longitude on a sign. And can you imagine trying to transmit that information if you were at that signpost or somebody was at that signpost? And also, does anybody have an idea what 0.5750 of a degree is? In contrast, on the right, we have an actual sign posted in Hawaii National Park. A Boy Scout used this for his Eagle Scout project. And so we have 20 signs posted on the border of a volcano area. The sign in this case is at 5 Queen, Kilo Bravo, 5539, 5264. This is an actual emergency location marker sign. These are being installed in multiple states. They can be installed in your jurisdiction with your leadership. Justifications for U.S. National Grid. Now, these are Florida documents, but your state and your jurisdiction could do the same thing. There's a Florida Field Operations Guide, there's a Comprehensive Emergency Management Plan, and there's a statewide emergency response plan. Two of those documents have been out for 5 years. One of them's been out just for 3 years. All are available on the internet, and the Field Operations Guide is available for your smartphone. So that information is available, and in your jurisdiction you can implement them or duplicate them. Also, FEMA, the Department of Homeland Security, and National Search and Rescue Committee all expect U.S. National Grid use during any major event and any wide area event. All land search and rescue as of 2011 is supposed to be U.S. National Grid. FEMA Directive 092-5 was issued in October 2015. I encourage everybody to search that document on the internet and read it. It is a very good document describing what FEMA is going to do in the future, immediate future, regarding all their partner agencies. They are definitely spinning up to make sure that everybody is using U.S. National Grid. The use of U.S. National Grid sets a platform of interoperability. USNGapp.org. That is for your smartphone. Try it out right now. USNGapp.org. It's a website. It works on any device. It's a free browser app. as GMAP4 is. It works on any device. It can function without the internet if you preloaded it in the browser. So if you pulled it up and then didn't close the browser out and you lost your internet, it still works. That's very handy. It can be used any time by anyone 24/7. Your dispatchers could talk to 911 callers who have a smartphone, or somebody else that's on scene that has a smartphone. Where is this location? I don't know. Do you have a smartphone? Try usngapp.org and read me the numbers. Consider promoting it to your customers, to your citizens, to your employees. In Volusia County, Florida, we had an actual helicopter crash on 3rd of September 2015. The initial dispatch location was 7 miles or 12 kilometers from the actual crash site. The helicopter pilot was awake and alert with some injury. He did not know where he was. It took over an hour for responders to find him. If he had usngapp.org on his smartphone, or if the dispatchers asked him to bring that up, the response time may have been shortened immensely. This is a picture of usngapp.org, what it looks like on your smartphone. The white letters are maybe less important for a regional area or local area. Read me the blue letters could be the first issue. Give me the blue, and if necessary, they could read the white. Web tools. GMAP4, Mission Manager. I used both of those to generate the graphics for this presentation. Both have free mapping product. Mission Manager is also working on a smartphone app. GMAP4 works on a smartphone at this time. GMAP4 has the ability to look at GIS data and display it, such as hydrants. They both have multiple layers. You can look at U.S. Geological Survey maps, aerials, many different map layers. Both should be available to any dispatcher and incident commander and staff 24/7. Put these web tools on your machines. They may be used to make hasty maps for issuance to field personnel in minutes. Again, a map without a grid is just a picture. Do not issue non-gridded maps to field personnel. It only takes minutes to make a map and issue a good gridded map to the field folks. And recall, a gridded map is a tool. In summary, U.S. National Grid is the National Standard Coordinate System. It's easy to learn, easy to teach, easy to use. It's a simple, one format only. If you're using U.S. National Grid, that's it. There's one format. Totally not true with latitude and longitude, where the different formats have sent ground teams far in the wrong direction when the numerics are put in the wrong format. National Grid is simple, single format. Gridded maps are value added. Leaders, you must put gridded maps in your apparatus, on your walls, in your vehicles, on your computers. We need gridded maps. Consider the emergency location marker for signage in your parks and trails. Helicopter landing zones or helispots can be done in 6 digits. All day long, helicopters are landing on over this nation, picking up patients. How are those helicopter pilots told where to land? It is a misconception that the latitude and longitude system shall be used for the helicopter pilot. The military clearly states that the ground operator shall be serviced by the ground operator's coordinate system. In the military, that's Military Grid Reference System. The U.S. Fire Service, law enforcement, emergency management should do the same. Go with simple helispot or LZ in 6 digits. Entrance doors and pre-plan information can be identified in 8 digits. Any building, front or back door, 8 digits. U.S. National Grid is a lesson learned from multiple prior events. The common operating grid is what has been stated as needed. U.S. National Grid is all about interoperability. U.S. National Grid is about preparation, having the maps in the vehicles ahead of time, having the maps on the CAD system, having the maps on the mobile data terminal. All of that is about preparation and readiness. Are you ready? If used daily, then nothing new will be needed to be learned during a major wide area incident. Anyone can be a USNG user in seconds via GPS, smartphone, whatever. Trail maps can be made, parking and camping maps can be made with grid on them. People that are hikers, day hikers that go to a campsite or a camping location, they can be issued gridded maps and figure out where they're at by a grid. So anybody can be a US National Grid user. Its prevalence is growing. Again, it is the National Standard Coordinate System. If you have any questions after seeing this presentation, would like more information, usng08@gmail.com is the email address. It also issues a 24/7 auto reply, which should get you started. And if you have a specific question, it will get answered. In addition, there's USNG Florida on Twitter, and there's usngflorida.org on the internet. I want to state special thanks to Chief Pete Lamb of Firefighting Today, who allowed this presentation to occur. I appreciate his input and his interest in U.S. National Grid and U.S. National Grid for the Fire Service. Firefighting Today. Thanks again for listening.